last 5 years or so, there have been huge advances in the methods that we can use for investigating brain function, and also in what we know about how the brain works. And these two things obviously go hand in hand. And so we've got to the point where the fMRI signal that we can look at, we've got a better understanding of what it represents, how to measure it, and how to analyse it using a variety of different techniques. So we have more sophisticated mathematical models to help understand the brain function. And we also have the ability to integrate information from different neuroimaging techniques. So there's been huge advances in so-called multimodal imaging, where we can combine the information from fMRI with PET or with MEG, and together that gives us a much more complete understanding of how the brain is working, how areas are interacting with one another, and the kinds of functions that they're supporting. The neural circuitry of depression is very complex, which reflects the complexity of the disorder itself. But I think we are making huge progress in understanding the neural circuitry of depression. We now have identified a key circuit which is involved in experiencing and detecting and regulating emotion. And so there's consistent evidence that depression is associated with overactivity of limbic areas, such as the amygdala and subgenual cingulate, and that these areas which are important for detecting and responding to important stimuli in the environment are normally kept in balance by homeostatic mechanisms involving the parts of the prefrontal cortex, which allow us to coordinate our response to emotional stimuli in an appropriate way to its context and its significance. So most emotional stimuli that we might have an initial response to actually